The basic of engineering is calculus. Now the question what arises is why calculus? The main question we have is why should we learn calculus? Correct? See, the whole calculus can be told in two terms. Okay, first of all, calculus. The whole calculus, only two purposes are there. First purpose of calculus, first purpose, okay, first purpose, to find the rate. Find the rate, okay, find the rate. Rate means the speed of change, okay, how fast something goes, okay, how something varies with something else, okay. So when you say rate, what does it have? We can say slope, we can find velocity, then slope of slope, double slope, we can find out slope of slope. Like that, you can go any further. Velocity, you can find out. Then you can find out acceleration. Then you can find out further. You can take a differentiation of acceleration also and find the what you say. What is the differentiation of acceleration? Okay. Yeah, I'll come to that. Okay. So like that, you can have it. Okay. Jerk, yes, very important. I missed that. Jerk, okay. Acceleration and a differential, you can find the jerk also. So these are all the different things we can have, okay. Second purpose. What is the second purpose? Second purpose of calculus is to find the area. Find the area. So whatever you're doing calculus, it comes here only. Find the area. Okay, these are the only two purposes of calculus, and everything goes with this only. Okay, so second purpose is to find the area. Now, because of this calculus, okay, so you know this, I am talking about differentiation, correct? I am talking about differentiation. This I am talking about integration. Now, wherever you go, whether you go with complex calculus, solving of differential equations, whether you are solving of even your finite element methods, what you have in structural analysis, or finite volume methods, all comes down to only these two purposes. You may talk big things, Navier-Stokes equation. You may talk about variation of stresses. Okay, you talk any advanced field. Okay, whether you say turbulence. Okay, in fluid mechanics, you talk about turbulence. You talk about in electrical or electrohydrodynamics. You talk about, or whether you talk about anything, quantum mechanics. Okay. You talk any field of science, this calculus is important, and it jots down to only two things. One is finding the rate, finding the area. That's it, done. Okay, there is nothing else which we do. Okay, there are some equations. Why we go with the differential equations? Because differential equations represents the physics. Okay, and in that physics, at the end, it is rates. When you say d by dx, what do you mean by dy by dx? Dy by dx is a rate at which y changes with respect to x, correct? A rate at which y changes with respect to x, correct? That is dy by dx. What do you mean by dou y by dou x? What do you mean by dou y by dou x? It means y changes with respect to many variables, but for now we are moving along x in such a way, we are moving along x in such a way that the other variables do not change. Other variables do not change. Okay, that means y that but x changes. Moving along x means x change, and we record the change in y. That is what is meant by dou y by dou x. Make sense? This is dou y by dou x, correct? That is what is the meaning. Okay. But now, first of all, you have to find out what is dy by dx. Correct. So if you say just dy by dx, not enough. You have to explain why dy by dx is there. That is done. Next, when I say second purpose, what is the second purpose? I said integration. Correct. What is integration? Finding the area under a curve. That's it. When you say, for example, when you say integration with respect to, I'll write it in the next slide. Okay, write this down, please. Any doubts here? Okay, you can write this down neatly. Next, we will go with limits. Like next, we'll go with integration. Next, we'll go with limits. First thing you have to understand why. First of all, what is it? Why are we doing it? Even if you don't know to solve whole of differential equations, if you don't know what is differentiation, that's fine. Okay, you should not. You should at least know why it is being done. That's it. That is the basics. Okay, what is happening in our PUC and 10 standard, 10 standard, 12 standard mathematics is that we solve a number of problems. ಯಾಕೆ ಮಾಡಬೇಕು ಆನ್ಸರ್ ಸಿಗಬೇಕು. ಯಾಕೆ ಕ್ವಶನ್ಸ್ ಮಾಡ್ತೀವಿ, ಡಿಫರೆನ್ಷಿಯಲ್ ಈಕ್ವೇಷನ್ಸ್ ಯಾಕೆ ಸಾಲ್ವ್ ಮಾಡ್ತೀವಿ ನಾವು? ಯಾಕಂತ ಹೇಳಿದ್ರೆ ನಮಗೆ ಆನ್ಸರ್ ಸಿಗಬೇಕಲ್ಲಿ, ನಮಗೆ ಮಾರ್ಕ್ಸ್ ಸಿಗಬೇಕು. Purpose is getting marks. Why are we doing this differential equations? Sir, I have to get into IIT. What will you do after going to IIT? Sir, then I will get into a good job. No, no, that is not the way. First is why differentiation. Yes, to find the rate. Why rate? Like that it has to go. So go from trying to what you say be something, trying to be something, trying to be an IITian, trying to be a what you say employee in somewhere. Try to see why it is done. Go to that higher level. Okay, and then you will see everybody will be under you. Okay, there's a lot of space at the top. Correct. There's a lot of space at the top. You go to the top, there is spacious. When you're down, it is very, very crowded. And core engineering is civil engineering students. Okay, people do not know this. Okay, because we see in terms of in terms of how much marks they get, how much salary a person gets. Okay, even in terms of salary, the civil engineer salary cannot be matched with any other engineers who is a true civil engineer. Okay, but unfortunately we don't realize, and from 1990s our level of engineering has reduced. The reason is because in 1990s our teachers did not get good payments, so the best of the teachers went to industry. Okay, so the teaching level in 1990s and 2000s reduced like anything. After 2010 onwards, teaching salaries have went up, but what has happened, those teachers have been taught by lower levels teachers, okay, who did not have conceptual knowledge. So what is happening? Our engineering has reduced. Before 1990s, I will say engineers was very good. Engineering was very good, and our teachers were very good. You can see the older teachers who are there in your college. Okay, ask them the basics. Don't ask them computer science; they will not know it. Okay, but ask them civil engineering topics. So ask them what do you say? Ask them the other things. They will have very good sound knowledge. Okay, because they have learned for knowledge purpose. They have not learned because at that time there was no campus selections. Okay, and civil engineering, mechanical engineer never had campus selections. Very less campus selections. Okay, so your best of the jobs is off campus. No company comes to the campus and pays you 20 lakh per annum. Nowadays it's happening. In NITTE there was one company which had come, LAM Research, which was giving 10 lakh per annum. Okay, but that is only for girls, mechanical. Correct. And there's one more company from mechanical. This time in NITTE they had come. They had given around 20 lakh per annum. Somewhere in Japan they have to go. Is it not? NITTE students may ask. Yeah, yeah.
BDEC.
Where is it asked?
BDEC.
BDEC. Yeah.
Japan.
Japan. So there are options also. Okay. But it is in Japanese currency, is it not? So let us have the 20 lakh per annum in India only. Let us get into NTPC. Okay. Yeah. Because we will be able to save that 20 lakh. Okay. If you go to Japan, you may be able to send only 5 or 6 lakhs. Others will go as to say expenses there. Okay. Shall we go further, students? Have you written this down?
Yes, sir.
Yes. Well, next is integration. Okay, what is integration? Okay, to find the area. Second purpose, to find the area. Now to find the area, what you do? If you have, say, x and you have y, this is very simple, students, but I'm reiterating. If you have a curve, what is this curve? Y is equal to f of x is the curve. If you find from here to here, say I will say x1 to x2. Okay. To find the area, what I do? I integrate. Correct? I integrate. What I do? I say integration of x1 to x2. Okay. F of x dx. What are you finding? You're finding this area. Correct? So this area A is that. Correct? So this is the only two purposes, students. Okay? Fine. Write this down. Now limits is very important. Okay, now dx, how small this dx has to be? Or if you consider dy by dx, how small this dx has to be? Dy means change in y divided by change in x. Now how do you define that? You define, say if you consider area, you say area is equal to, okay, area is equal to of summation of small areas. For example, you say small areas here. Okay, this small area. Okay, so I will say summation of, say, from 1 to infinity, 1 to infinity. Okay, we can go with n is equal to 1 to infinity. Okay, we can say summation of, say, delta x, summation of delta x, where delta x tends to, sorry, delta x tends to 0. Okay, delta x tends to 0. Summation of delta x into this y. So summation of y delta x, which gives the area, into the number n. Correct? Oh, sorry, that number is the area. That is what it means. Where delta x tends to 0, this is what is the meaning of integration. Okay, when delta n tending to 0. Correct? Sorry, delta x tending to 0 or n tending to infinity. Correct? That is what is meant by integration. What about differentiation? When you consider dy by dx, what does that mean? It means limit delta x tending to 0, y2 minus y1 divided by x2 minus x1, or here I can say x2 minus x1 tending to 0. X2 minus x1 tending to 0, or this can also be written as limit delta x tending to 0, delta y by delta x. Always keep in mind, when we say delta x by delta y, I'll write it here. Whenever we consider delta x by delta y, if you have a curve here, y is equal to f of x. Okay, it means x1, x and y. If I put here x and y, it's always when you have to take a slope, what you do, you take, this is always x2, this is what is x1. Okay, and this is y1, this is y2. So what we are taking, we are reducing this to almost 0. That means you are coming to a point, and then you say what is dy by dx. So dy by dx at a particular point is what we define. And when you say it is y2 minus y1 divided by x2 minus x1, very important to remember. Okay, write this down, students. Next we will go with limits.
Sir, can you explain once again A equal to sigma n equal to 1 to infinity?
Correct.
That,
See, what is happening here is, when you say summation, what does it mean? It means that when you have this, we are going to cut this down into small portions. Small portion. How small? Very, very small. How very small? So small that it is very, very small slice. And that slice will almost go to 0. Because every time y is different. See, for slice 1, y is different. For slice 2, y is different. Correct? So y into delta x gives the area of the slice. Make sense? Make sense? And this area of the slice, we have to add it up till here. Correct? So you add it. Okay? That is what is the definition of this integration. Make sense? Make
yes,
sense?
sir. Yes, sir.
Okay, small slices you add. Okay, all the small size area you add, only then you will get the total area. Okay, and how small the slice has to be? Slice has to be very, very small. How small? Very, very small. Okay. So how small we cannot say. Okay, but on
So like
a,
there was delta x tends to 0, so I didn't get that term.
okay, now
How
your
delta x?
delta x is this. Delta x is this. This is delta x. Okay. I actually did not tell you that. Okay. Sometimes I skip things. Okay. Fine. Clear. So delta x, the small things. That's why you have to ask questions.
So delta x tends to 0 means it is infinitely small thing.
Infinitely
So we are
small.
assuming. Okay,
Yes.
sir.
Yes. Yes.
And in limits, sir, like in differentiation.
Differential limit delta x1 x2 minus x1 tends to 0 means this becomes very, very small. This is becoming very, very small. It is coming very, very small. So what is happening? We are coming near and near. Okay. So if I have this particular curve, I'm sorry, I'll write it neatly. Okay. So if I have this curve, okay. So what I am having, when you say x2 minus x1 tends to 0, I am coming from here. First this one, very broad. Then you come here, close, closer, closer. Okay. And then you say what is the change in the y. Make sense? Initially y may be here like this. This is the initial change. Second change would be this. You're zooming, zooming, zooming. Okay. And you'll get at a point. Okay. Make sense?
Yes,
Make
sir.
sense? Yes. Imagination is powerful than knowledge. Who said that? Albert Einstein. And he's correct. There are a lot of wrong things Albert Einstein has told. Okay. But not everything is wrong. Most of the things are right only. Is it not? Although he was a bit eccentric, because only eccentric people can do wonders. Straight people cannot do. Correct? You have to, original thinkers are like that only. They go something different from the society. They take risks.
The both term means the same, right? Integration and differentiation.
Doesn't mean the same. How come?
Similar.
No. Integration is the slope. Area is sorry. Integration is area. Differentiation is slope. Simple and straight.
In differentiation, we are continuously finding the slope.
We are not. Yes. 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 In
Yes, sir. Okay.
differentiation, at a point we are finding the slope.
Okay.
In integration, we are adding up things.
Okay. Okay, sir.
Okay. Very simple. We have been doing this again and again, but still we have to get these things, we have to refresh again and again, because this will improve our understanding. Okay, let me tell you students, in solving problems, okay, if you have to solve problems, you need practice. Okay, and you need something called a riyaz. Very important. This person is very important. I will name some people. I don't know whether those people will be there in the class or not there in the class. I'm not aware, but I'm not talking about a person there. I'm talking about things there. I'm talking about concepts. Okay, so once it is there, I will tell the concepts here, the studying concepts, which I think my students, they have heard a lot of times. Okay, they are tired of hearing, but still they hear it. They just like, you say some of the things you hear again and again, still you don't get tired, is it not? Similar way, this is, we are in a religious group, student. Okay, we are in gate religion. Okay, now, okay, so there are some rules here to follow. Okay, the first rule is you should not forget riyas. Okay, you know what you mean by riyas? Riyas means practice. Okay, practice is very important. Now how do you do practice? You have to close your eyes, imagine. Not writing, all the writing has to be done, obviously. If you don't write, you will not be able to recall. Okay, but write and then recall. Close your eyes, see whether you can recall those formulas, you can recall those concepts. Imagine, imagine, imagine. Okay, then you will get questions. Ask, imagine, ask, imagine, ask. Okay, I will introduce some more people also. Okay, Riaz is one person who I am introduced now. Okay. Another person I want to introduce is Shraddha. Okay, you have to be on that thing. You have to understand. You have to think. You have to be there. Okay, Shraddha irbeku. Okay. Second thing I want to introduce is Shraddha. Very important. Riyaz, Shraddha, Viveka. Another person. Okay, very important. You have to differentiate what is right, what is wrong, what is correct, what is wrong. Okay, the differentiation is Viveka. Okay. Done, students? Can I go further? We'll go to limits.
Yes.
Yes, very good.
Yes, sir.
Now, let us not go about the philosophy now. We'll go to limits. Okay. Philosophy will come later on. Okay. So, now, first of all, what do you call as limits? Let me tell you. Okay. See, there are some, we'll go with limits. I will not give you the formal things. You have done it. You know all the formal things. I'm not going to that. Okay. So, if I take a curve, for example, okay, this is to make you understand because in gate it is not to reproduce wonderful uh, definitions. It is to understand and being able to put the definition on your own words. That is the strength you have to get. Okay. So now if I have a curve, for example, now in case this curve is not defined for a small amount here, in case it is not defined, okay, possible. There are cases when a particular function f of x, say y is equal to f of x. Okay, it is possible at some place it is non-defined or it is undefined, right? It is possible that it is undefined at that place. Say for this place, it may be undefined. F of x is undefined in this region. Possible. Okay, if f of x is undefined in this region, we will see whether we can reach that particular point as a limit. Okay, now let us take an example because if you don't take the example, we will not be able to get the things. Let me see, students, one of the WhatsApp message I have got because you people when you call, okay, so you can give a WhatsApp message and I can set that. Okay, so yeah, so here now what is happening here, it is not defined. Example I have to give. Without example things will be not so clear. Okay, so let us take an example. Say take f of x is equal to, let us take f of x is equal to x square minus 4 x square minus 4 divided by x minus 2. Now keep in mind this is f of x. The simplification of this is not f of x. If you simplify this, that is not f of x. The way it is there now, the way it is defined now, that is f of x. And if you see, this f of x is not defined at x is equal to 2. Okay, so f of x is undefined at x is equal to 2. Why? Because when you substitute x is equal to 2, you get substitute 2, x is equal to 2 in f of x. If you substitute x is equal to 2 in f of x, what do you get? You get f of x is equal to 2 square minus 4 divided by 2 minus 2. What do you get? You get 0 by 0, which is undefined. Correct, students? 0 by 0 is undefined, is it not? You cannot divide 0 by 0, correct? So it is undefined. So at this place, f of x is undefined. For example, if I see, okay. Now what to do next? If it is undefined, we will see whether we can approach this as a limit. Okay. If f of x is undefined at a place, at a location, Okay, we will see whether this can be approached, this location can be approached as a limit, whether this point can be approached as a limit. What does that mean? We will move, so the x is varied, x is varied in such a way that x is varied in such a way that, okay, the value of x value of x approaches the x value which is undefined, and we try to we try to uh, we try to approach a specific value of y. How does that happen? We will see with this one. Okay, next slide we will see this. Very, very important basics. Why is has to be answered first. Then comes everything else. Why? What? First question. Then how? Why, what, and how? Or what, why, and how? What is that? Why we should do that? Okay. Then how should we do that? Students, evening we will start with linear algebra by Manoj sir. Okay. So from his approach is a bit different. Okay. See, mine is a bit more than our what is required for gate. He concentrates on what is required for gate. Okay, both approaches are important. Okay, and then evening we will have Murali sir giving for civil engineers. He will start with structural analysis, and he will start with the transportation. Okay, yes. So I have this timetable. Let me show the timetable to you. See, this is the timetable. Okay, structural analysis, transportation. Okay, so you can take the screenshot if you want. Tomorrow morning, Shiva Mahantesh will start with geotechnical. He's a MTech from IIT Madras, PhD from IIT Madras in geotechnical. Okay. Yeah. I hope you have taken the screenshot, students. Okay. And somewhere about 30th, 30th August onwards, our for mechanical engineers, vibrations and machine design, our Murali sir will join. Okay, he will be taking classes from around 6:15 to 7:15. There is a change. I'm sorry. Here there is a change for today. Okay, today there is a change. I'll say again. Okay, the change is this will be from 6:15 to 7:15. Let me put it again. The linear algebra class today will be from 6:15 to 7:15. Okay, I'll repeat again, 6:15 to 7:15 today. Okay, not from 5 to 6. Okay. Students, kindly save my number in your mobile, because I will broadcast these messages. Okay, from now onwards, I'll broadcast these messages. I'll make a new group where students are there, so you will get individual messages. Okay, you will get those messages only if you have saved my number in your mobile. Okay, otherwise you will not get it. Okay. Done, students? Write it down neatly. Tell me when you're finished. When you have finished, don't wait for others. Person who has not finished will say, I have not finished, sir. Give me more time. That's it. And write it neatly. Very important to write notes very neatly.
Done, sir.
Yeah, very good. Next, let us take an example of this only, and we will see how we approach this as a limit. For example, let us take, what is f of x? We know f of x is x square minus 4 divided by x minus 2. Correct. Let us take, say, we will say there is something called left hand limit. Left hand limit. We approach things from the left hand side of the screen. Okay, limit. Okay, left hand limit. And then we have right hand limit. Okay. Let us understand this, because we have been given this a number of times, but sometimes some people, not everybody, some people don't understand this. Okay, let us understand this. Say, let us take, for example, say this is equal to y. Okay, y is equal to f of x. So let us take x is equal to, what is it undefined at? 2, right? It is undefined at 2. Let us take 1.9. What is y at 1.9? You calculate. Then you go for x is equal to 1.99. Then you take x is equal to 1 point, or let us go with 1.5. Let us go with 1.5, then 1.9, then 1.99. Then we will go with 1 point, x is equal to 1.999. See what is the y you get. And similarly here, you start from the bigger limit. Okay, say x is equal to 2.5, then x is equal to 2.1, then you take x is equal to 2.01, then you take x is equal to 2.001, and see what are the y's. Just do the math. I will also do the math. Okay, so what happens? Let us open calculator here. Okay, let us do the math. Okay, so what is it? X square minus 4. So 1.5 square, correct, divided by 0.5, correct, 0.5. So what is it? 4.5 you get here. Observe, this comes as 4.5, correct. Next, let us take again here. Let us take again. So 1.9. So what we have here? Clear? Okay. So 1.9 square, okay, minus 4, correct, divided by we can have here, I'm sorry students, it's not 4.5, it's minus 4.5, no, plus 4.5 only, correct. So x square is very sorry, this you tell me students, what is it? Okay, let me see this is wrong. Okay, this one which we have solved is wrong. Okay, so minus 3.9,
3.5, sir.
3.5 is it? Okay.
Yeah, yeah.
3.5.
Okay, 3.5 divided by, let us say, 1.9 minus 2, which is minus 0.1, correct? So that comes as, oh, sorry. You tell me, students, I am getting this one. You tell me what we get here, okay? What is this one? This is 3.5, is it?
Yes, sir.
Yes.
Right. What is this? Second one. What is this? First one is 3.5. Keep on telling me these numbers.
3.9.
3.9. This number. Next one. Next number.
3.99.
3.99, correct? 3.99. This number. Another 9 you get, is it not? That's it.
3.999.
Correct. Tell me this here on the right hand side, right hand limit. 2.5, what do you get y as?
4.5.
I know this, huh?
4.5.
4.5. This one.
4.1.
4.1. This one. Next one.
4.01.
Very good. 4.01. Then you get 4.001. So what is happening is, when you go, say this is a curve here, okay? This is the x and y, okay? X and y. So as I approach, say x is equal to 2 from left hand side, this is from left hand side, okay? And then from right hand side, what I get, you get the value of y approaching this 4. So when you go from left hand limit, it approaches this point, and when you go from here, it approaches like this, correct? So this is the approach, but we cannot reach at this point. We cannot reach, we cannot say x is equal to 2, because when you say x is equal to 2, it's undefined. So we can approach that. We can approach that particular value as a limit. That means it does not go at that point. It comes nearer and nearer and nearer. That's it. Okay. So if here in this case, when it approaches from right hand side and left hand side, if the value it is approaching is the same, then we say limit exists. Okay. So I'll write here, if the value of y, if the value of y that is obtained when we approach from right hand side and left hand side is approaching the same value, then we say limit exists. What does that mean? For limit to exist, right hand limit should be equal to left hand limit. If that does not happen, limit does not exist. Simple and straight. Make sense? Basic thing. Okay. So left hand limit should be equal to right hand limit. Then limit exists. If it does not happen, limit does not exist. Simple and straight. Let us take an example and see. So I'll write it mathematically again. Okay. Again and again repeat. I say Doha, Kabir Doha, okay, which is very this one. It says Karat karat abhyasate jadamati hot sujan. If you do practice again and again, karat karat abhyas, which is told by Kabir Das, okay, doing karat karat, doing abhyas, okay. I'm just literally translating from English to from Hindi to English, okay. karat karat abhyasate jadamati. Jadamati means the person who doesn't have intelligence. Okay, jadamati hota sujan becomes very very intelligent, seems intelligent by practice. Only practice makes you intelligence. Very 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 important. Okay, today some people you may feel they are more intelligent than us. Why that intelligence has come? Because when they are young they practiced, simple and sweet, nothing great, or they were in the environment where it was good. Okay, so it's very important. If we were not there in that environment, now let us create that environment for ourselves. We cannot change the a lot of factors, we will change what we can do. Okay, so that is, and once we are adults, then we can obviously do things. Right? We are not kids anymore. Correct. So we know how we can create our own environment in our mind. Okay. Yeah. You will be what you think you will be. Okay. You will. If you think bad, you will be bad. If you think good, you will be good. Simple and straight. Your thinking has to be channelized. Done, students. Write it. Write it neatly. Write it. Done. Well. So let us put it mathematically now. Okay, what we can say mathematically, very important. Okay, we say limit extending to lambda minus. In the example we have taken, lambda is equal to 2. Okay, lambda minus means we are approaching 2 from negative. Okay, from the value which is lesser than 2. Okay, f of x is equal to limit extending to lambda plus. If that is equal, then limit exists. In case limit extending to lambda minus f of x, I'm sorry, f of x we have to write here, f of x is not equal to limit extending to lambda plus f of x, then limit does not exist. Does not exist. We say DNE. DNE, which stands for does not exist. Simple. Let us take an example where limit does not exist. One of the example is limit example. Let us take. We have seen where the limit exists. Example for limit exists is we have seen what is the value we have seen. Example for this we have taken already, which is x square minus 4 divided by x minus 2. Correct. And we set the limit of this. Okay. Limit of this. So limit, I'll write it here like this, students. Okay. So limit exists. Okay. So here for this limit extending to 0. Okay. Or we can say, yeah, this whole thing, limit extending to 2. Correct. Extending to 2. This is equal to how much? Is equal to 2. Sorry, is equal to 4. Correct, students? Why? Because when you approach from the left hand side, when you approach from the right hand side, you approach the same value. Correct. Now here in this case, example, another example for not having that is this. Okay, it is limit x tending to 2, magnitude of x minus 2 divided by x minus 2. Now for this limit does not exist. Let us do the example. Let us take for x tending to 0. So if you put x is equal to 2, what happens? 0 minus 0 is 0. 0 by 0 we get, correct? But let us approach this as a limit. Let us see. Okay. So let us go with say a right hand limit, sorry, left hand limit and right hand limit. So let us go with left hand limit and right hand limit, and let us evaluate this. Okay, so here if you consider x is equal to 1.5, what is y you calculate? X is equal to 1.9, what is y you calculate? X is equal to 1.99, what is y you calculate? X is equal to 1.999, what is y you calculate? Okay, similar way you can say x is equal to 2.5, what is y? Okay, x is equal to 2.1, what is y? And x is equal to 2.01, what is y? You calculate, students, and tell me. Okay, x is equal to 2.001, what is y? You calculate and tell me what does the value approach as? What is limit x tending to 2 minus left hand limit? Okay, what is x minus 2 divided by x minus 2? What is the value you are getting? Similar way, tell me if x limit x tending to 2 plus x minus 2 divided by x minus 2, what is the value you are getting? Tell me that. Thank you, Vivian. Students, kindly use a scientific calculator only, the one which is there as a gate calculator. It is available in your mobile phone. Okay, so you can download gate calculator on your mobile phone. I have downloaded it, but I don't use it often. Okay, there is something called inertia in me. Okay, kindly you do not get into those inertias. Okay, gate calculator is there. Free of cost available. Okay, yeah, so calculate that. What is the first one, student? Tell me. Tell me what does this come as? Fast.
-1.
Minus 1. What is this?
All -1.
All are minus 1. Correct. What is this?
1.
All are 1. Correct.
Yeah.
Correct. Good. So as it approaches through this, it becomes minus 1. This becomes plus 1. That means left hand limit is not equal to the right hand limit. So limit does not exist. Makes sense? At x is equal to 2, limit does not exist. So what happens? Limit extending to 2 minus, okay, of f of x is not equal to limit extending to 2 plus of f of x. So limit does not exist. LDNE. Correct? Done. Simple. So I know these are some things which you have done in PUC also, but it is just a refreshment. Okay, I'm not telling you something, some concepts which you do not know. I think you know these things, is it not, students? I'm just refreshing what you have done in your. Okay, simple. Now next we will go how to solve these problems. Have you written this down, students? Tell me when you're finished writing. Then we will go with. So what is happening? So for x is, let me put this in the next slide once you finish. Finish, students? No?
Yes, sir.
Done. Okay, good. Okay. So next point. Okay, you have to say yes. One person has to say yes. Okay. Now, in case we have to find some limits, what should we do? Okay. For example, let us take an example. Okay. First thing, see, whenever you have to do a limit, first one is try substitution. Try substitution. First step. Okay. Sometimes two substitution only will get limits. For example, if I say limit x tending to 3, x square minus 2 divided by x plus 3. What is the answer for this? The answer is try substitution. Okay. Now you may ask, sir, x square minus 2, x plus 3 is defined. For example, if you substitute here, you will get 9 minus 2 divided by 3 plus 3, correct? So that answer will come as, what is correct? No, 9 minus 2, 7. 7 by 6, you get it. Then why, sir, you are using limits? Okay, see, limit is not just for the things which is not defined. Okay, the limit can be approached for any point. Very important to understand. When you consider limit, okay, it may so happen it is defined at a place. It is defined at a place. Still, when you approach from both sides, you will come down to the same limit. Although it may be trivial, this is trivial. It's a trivial concept. What is there? Okay, what are you saying? So limits. Okay, limits is only useful when it is when you have it undefined. Okay, but no, there are cases when you do the problems. There are places where you cannot what you say you will not be able to guess. So whether it is defined or not defined. So first one is try substitution and find it out. So what will come as 9 minus 2, 3 plus 3, 7 by 6. That means this implies that the function f of x is defined at lambda, but still which can be approached, which can also be approached, which can also be approached as a limit. And only these things can be seen using substitution. So first one always is try substitution. Write this down, students. Now if it is not defined, this try substitution is gone. So we are going step by step. For example, if you consider limit extending to 2, x square minus 4 and x square minus x minus 2, okay, this when you substitute, you will get 0 by 0. Okay, function is not defined, limit we will see it later. Okay, so function is not defined. So function is not defined, we cannot do anything. Okay, if you go with only one substitution. So we have to go still further to see the limits. Okay. So next point. Okay. This is the first one. So step by step we are going through this. Okay. Write this down. And after this, I'll tell you, you will be able to solve any limit questions. The approach I am going is not the traditional approaches. Okay. First easy, then going step by step, we are going to make it tough. Okay. And in fact, here my what to say, my aim is to make it such that all the tough concepts will be coming easily. That is my purpose. Okay, that's the purpose of teaching, is it not? There should not be any tough concepts at all. It might be long but not tough. Okay? It might be big but not what you say. It might be big but not very what you say, not able to handle. It's not so big that it cannot be handled. Okay, somehow the other way. We will give you tools so that you can handle that. Okay.
Done, sir.
Done. Okay. Vishal Shetty wants to join the demo classes. Okay. Uh, just a second, students. Send me their email. Okay, done. Okay, let us see now. Next. Okay, so function has to be defined, correct? So next point. Okay, second one is factorize. Second one is factorize. Now, how do you do it? For example, limit x tending to 2. I'm using the same uh, example, students, so that we will understand, is it not? X minus 2. This we can factorize. How we can do it? Second step. Any question we have to solve, first try substitution, second try factorization. Okay. So now what we will do? This is limit x tending to 2. Here x minus 4, x square minus 4 is x plus 2 and x minus 2. Correct. And then you have x minus 2. So x minus 2, x minus 2 cancels. No need of doing those long things, approaching from right hand side, approaching from left hand side. You can find the limits just like that. So this would come out as limit extending to 2, limit extending to 2, we have x plus 2 and the answer comes out to be 4. Make sense? So second step would be factorization. If you factorize, you may get the answer. Okay. And very important here. Okay, let us see again one more thing. Okay, let us take another example. Take limit x tending to 3 and you have x square minus 2x minus 3 divided by x square minus 9. And this, when you factorize, you will get it as x. This can be written as limit x tending to 3. We can write it as x plus 3, sorry, x minus 3 and x plus 1. I hope you know how to factorize, students. So then you will get x plus 3 and x minus 3. Correct. So x minus 3 can cancel. And what limit remains is limit x tending to 3. We have x plus 1 divided by x plus 3. And the answer comes out to be 4 by 6, which is equal to 2 by 3. Make sense? Second step. Now, in factorization, there might be places where we may come across these limits. Okay. Vishal Shetty. Okay. 1 second, students. I will send Vishal Shetty this one. Just a second. Link sent to email ID. Class is going on. You can join the class now itself. So now, if I consider here, okay, so just a second, students. Okay, so now here when you do factorization, there is one trouble which comes. Not all you can solve. Just like this, in the first time when you tried substitution, you if you get in terms of 0 by 0, you cannot proceed. You cannot use this. You have to go to the second type, correct? So here second type we go with factorization, and there might be places where you will get something like this: limit x tending to 0, 1 by x. Possible that you can get it, correct? That will go as 1 by 0, and this does not exist. Very important. So you have to go to some other method, okay? Or you may get a limit x tending to 0, 1 by x raised to n. This will tend to infinity. You can say it is infinity, the value is infinity, or you can say does not exist, okay? Another point you may get is something like this: limit x tending to 2, square root of 1 minus x square. It's like this. If you get, you will get this as square root of minus 3, complex. So it will come as complex, and we say it does not exist. Complex things does not exist. Okay. So like this, if you get, then you have to stop. Factorization has failed. So we have to go to the next. Okay. If factorization fails, we will go next step. Yeah, we can always do that approach from the right hand limit, approach from the left hand limit, and find it. But what you have to do, you have to solve this again and again numerically, is it not? Here you can do it analytically. Okay. And when things are complex, it becomes really a hell to solve all the things. Okay. Hello, Vishal. Vishal, the class is going on now. You can join the class now itself. I've sent the link to your mail. Yeah. Done, students? Write it down. Don't. There's no need to rush. Okay. So I'll repeat again how the thing. Okay, write it down. Then we will see. We'll see whether Vishal has joined. Vishal Shetty has joined. Very good. Okay. So first level is to find out substitution. Second is factorization. And factorization will fail when limit extending to 0, 1 by x term comes, or limit extending to 0, x raised to n term comes, or if x tends to that goes as a complex numbers, correct? Yeah. Students, one of the main thing what we have not done in engineering is study the basics properly. Okay, we have just score marks. Okay, and because of that, our gate we are not able to clear. And gate is very simple, simple exam, students. Okay, it is not tough exam. Because we know the concept, we are having the problem. Okay, and for concept it takes time. You don't have to be extra intelligent to have gate. You attend the classes enough, you'll clear gate. Okay, provided you don't panic, very important, don't panic and you study. Okay, that's it. The moment you panic, you're gone. Study with that childish environment, childish thinking, childlike thinking, not childish, childlike thinking, where whatever is presented to him, he will feel very happy. Is it not? A child will feel happy, correct? That kind of pure mindset, with that you have to study. A child is the person who studies anything very fast. Why? No complications, correct? We are adults with a lot of complications. That's why we feel it difficult to learn something else. And if you see IIT professors generally, they are childlike, not childish, childlike. Okay, in their study. Okay, and this is one of the things what my professor used to say, that these teachers, they might be strict. Okay, but they're not malicious. Very important to understand that. Okay, most of the professors who are really professors, okay, they're not malicious. They are subtle, but they are subtle but not malicious. Subtle is to understand them, it is difficult. Okay, they are subtle but not malicious. Very important. It is something told to God. Okay, God is always subtle but never malicious. Sukshma, in Kannada, if you have to say sukshma, ಅರ್ಥ ಮಾಡೋದು ಸೂಕ್ಷ್ಮತೆ ತುಂಬಾ ಕಷ್ಟ. ಆಯ್ತಾ? ಅರ್ಥ ಮಾಡ್ಲಿಕ್ಕೆ ಕಷ್ಟ ವಿನಃ ಯಾವತ್ತು ಕೇಡ್ ಮಾಡಲ್ಲ. ಹಾಗೆ ಪ್ರೊಫೆಸರ್ಸ್ ಕೂಡ. ಆಯ್ತಾ? ಸೂಕ್ಷ್ಮತೆ ಇರುತ್ತೆ, ಆದ್ರೆ ಕೇರ್ ಮಾಡಲ್ಲ ಯಾವತ್ತು. ಆಯ್ತಾ? ಯಾ ಸ್ಟೂಡೆಂಟ್ಸ್, ಡನ್?
Yes, sir.
Yeah, tell me any doubts? Done?
Yes, sir.
Yes, very good. Okay, so next point. Okay, another point is cut a common denominator. Third point, which third step to solve it is cut a common denominator. Third one is to cut a common denominator. That's the third part. Okay, so example is, say limit x tending to 0. Okay, I know I am taking very simple problem, students, because simple problems, when you take, you understand. Once you understand, apply it to the complex problems. Okay, that is my way to go. Okay, first always to understand concepts, put it to simple problems. Okay, now this one, if you apply x is equal to 0, what you will get? X is equal to, first one is substitute, right? First step, substitute. When you substitute, what you get? Substitution, when you do, you get 0 by 0. You can see that, is it not? When you substitute, you get 0 by 0, correct? Because 1 by 5, x is equal to 0, you get 0 by 0. What was the second step I said? Second step is to factorize. Not possible, so substitute, gone. Okay, second is factorize. How can you factorize this? If there is a this one, not possible, so factorize is not possible. So next is cut a common denominator. Can we do that? Let us see. Okay, so this one can be equal to limit. This generally you will do it naturally, students. Okay, minus 5 x plus 5 divided by 5 into x plus 5, correct? divided by x. This you will do naturally. I don't have to tell you this, is it not? And this, when you do further, you will get this as, one second, students. You will get this as 5. So you will get this as limit x tending to 0, limit x tending to 0, 5 minus x minus 5 divided by 5 into x minus 5 divided by x. Correct? This is a big divide. Okay, so this will come as, this becomes equal to, I can say, limit x tending to 0. We get here, this is minus x. Correct? You get minus x divided by 5 into x minus 5, and here you will get 1 by x. So solving it, then try substitution. You can cancel these two, then try substitution. So this is equal to limit x tending to 0 minus of 1 by 5 into x minus 5. So the answer you get is minus 1 by 25. Make sense, students? So this cannot be done for everything. If there is a common denominator, we can cut it. Okay, yes. That's the next.
So how that became 5x minus 5? Or
Because
5?
this is what is common. What is LCM here? 5 into x plus 5, not x minus 5. I'm sorry.
Okay,
My bad, my bad, my bad.
sure. Thank you.
Yes, my bad. It is x plus 5. My bad, students. So this what you have written, that itself you can solve all the problems that comes in GATE. You don't require any other materials other than this. No need of any textbooks also. Okay, whatever I have written it down, whatever we have made you to write on your notes, that's more than enough, students. Okay, because here you're understanding the concept, and then we will solve all the problems. Okay, and our aim is that you will be able to solve all the problems, not me. Okay, if I solve, that is a different case. You should be able to solve. What is the use if I solve all the problems and you are not able to solve? Is it not? I am an intelligent guy, you are a fool. That's how it will come, is it not? Even if I am a fool, it's okay. You should become intelligent. Okay. Sometimes I do small mistakes. Agreed. Okay. But what is important, you should not do mistakes. Tell me when it is done, students. We will take 5 more minutes. Okay. One more concept we will do and then we will stop.
Done.
Done? Okay. Next one. Next point. There are cases where you have to rationalize. There are cases when you have to rationalize. Example. Take an example of limit x tending to 8 square root of x plus 1 minus 3 divided by x minus 8. Now if you see this, when you apply x is equal to 8, you get 9 minus 9 is 3, 3 minus 3, 3 minus 3 divided by 8 minus 8. That will come as 0 by 0. Substitution did not work, right? So substitution failed. Okay, substitution failed. Okay, next point. Okay, let us go with another one. What is there? Next one, you have to rationalize. If you see, if you can factorize this, you cannot factorize, right? Factorization cannot be done. Factorize cannot be done. Next is, after factorization, cut a common denominator. Cannot be done. So next is rationalize. Okay, so rationalization, when you do, what you say, this is equal to limit x tending to 8, okay, square root of x plus 1, correct, square root of x plus 1 minus 3 divided by x minus 8 into square root of x plus 1 plus 3 divided by square root of x plus 1 plus 3, correct. So this is there. So this will be equal to limit x tending to 8. You can factorize this, you get x plus 1 minus 9, and here we have x minus 8 into square root of x plus 1 plus 3, correct students. And this we can write, we have rationalized, okay. So this when you apply, okay, you will get this as limit x tending to 8, x plus 1 minus 1 is x minus 8 divided by x minus 8 into square root of x plus 1 plus 3, correct. Now you will see x minus 8 gets cancelled. You can write limit x tending to 8. We can write it as this one by square root of x plus 1 plus 3, and the answer you get it as square root of x plus 1 is 9 plus 1, sorry, 8 plus 1 9, root is 3, so you will get 1 by 6. Make sense? Rationalization. If again I say substitution, if substitution fails, factorize. If factorize fails, cut a common denominator. If that is failing, then rationalize. Some more concepts we will see tomorrow. Okay, by tomorrow I think we will complete limits. Then we will go with differentiability. Sorry, continuity. After limits we'll go to continuity. After continuity we will go with differentiability. We will solve the problems which has come in gate tomorrow on limits. Okay. Limits is one thing, 1 or 2 marks questions comes, and the way we have gone, you can do it easily, students. Okay.
Sir, in factorize,
Hmm.
you have given one example, right?
Yes.
There x square minus 2x minus 3. Sir, how
Hmm.
can, if there is a x cube or x fourth value, how can we split into that, sir, manually?
Manually, it is when you have x cube, it's always difficult.
Okay, sir.
I will tell you methods. Okay. You have
Okay, sir.
something called there's a lot of division types which are there. Okay. I will tell you those methods. Okay. But generally, x cube when it comes, it becomes difficult. Okay.
Okay, sir.
And you have to get a factor. Okay. We have to see
Yes,
whether
sir.
you have to see substitution there. Okay. Or if x power 4 comes, then you have to see whether we can say x square is equal to say y. Then substitute and see whether
Okay,
we
sir.
can solve that problem. Got it? So that way we have to
Yes, sir.
go. Okay. Various methods are there for that also.
Okay, sir.
But not all you can solve. There are some things which is unsolvable. You put just like that some equation there and say solve it. Maybe it may not be possible. Correct. That is why you have some equations whose roots cannot be found. It has to be found using numerical methods. Some random things if you give, it may be so that you will not be able to find the roots. So we have to go with Newton-Raphson method to find the roots. That we will see in numerical methods.
Okay, sir.
Okay. So you may ask like this, sir. Then in the reality, if we come across that, then what? Reality can be very different, is it not? What questions comes to you is what answers is possible during that 1 minute or 2 minute time. Okay, whichever can be solved. Only such questions will come in gate. But when we go to reality, anything can come. Okay, there when it comes, then what you have to do? You have to go with numerical methods. That's why we have computers. We are doing with CFD. We are going with finite element methods. Why are we doing it? Because that things has to be solved Okay, using, we cannot solve it by hand, so we go with computers. We have to be very thankful to Alan Turing. Correct. Turing was the first person to envisage this thing. Alan Turing. Correct. Alan Turing. Okay. The person who won the war for British, because there was something called Enigma code. You know that, students? The Enigma machine was there, which was sending codes to Germans had seen this Enigma code, and this Enigma code was being able to send military messages across to Germans. Okay, and it was very important for Britishers to decode. Okay, and Alan Turing to decode this Enigma machine, he did his own computer. Okay, it was very big with all, in the sense, it was in 1940s. And it's a very sad story of his. Okay, he was a gay, and what to say, he was imprisoned for that. Okay, very sad story. Yeah, he committed suicide later on. That is how thankless some people can be. When we become more rigid students, we lose a major thing called, to say, orthodox, rigid. These kind of people, no, they lose the basic thing called compassion. When you lose compassion, you're not no longer a human. Okay, so with the Britishers also, British anyhow, we know how, we have seen for more than 200, 300 years how British were, how brutal they were, is it not? Okay, anyhow, chalo. Yesterday was Independence Day. Okay, so today we are really happy to be independent actually. See how Afghanistan is there today. Okay, nothing to question. What about freedom of speech? No, don't talk about freedom of speech. Freedom of life is not there. So we have come above all those things. Okay. Done, students. Thank you very much. Okay.